Next, let's talk about input-output. Previously, we mentioned that I/O comes in parallel, which is a bunch of bits at the same time, in serial, which is one bit at a time, analog, and time. Today we're going to focus on parallel. So we're going to create a reconfigurable port. And a port will have two types of signals. We could have input pins, which allow digital signals to enter the computer. Remember here, they're 0 volts or 3.3 volts. And when we input, this logic level is converted to a true or a false, a 0 or a 1, a false or a true, where 0 is mapped to 0 and 3.3 will be mapped to 1. That's the input. On that same port, we can have outputs. And as you can see, the individual pins of the port could be an input or an output. So when we output to a parallel port, when the software outputs, the 0 or 1 that we output to this port is then mapped to a 0 volts or a 3.3 volts. So, to see this reconfigurable port, we're going to look at how it works. One of the things that the software can do is read from the port. And what happens when the software reads from the port, the value on the pin is then mapped onto the bus and we can read it. The next thing that we could do is write to a port. And if we write to a port, what happens is the data is then latched into a register, and if properly configured, that register will then write to the pin. And in order to control this reconfigurable port, we're going to need one more register called the direction register. And so if we write to the direction register, this latch here will control a pin which controls that. And so to see how this works, we're going to look at the two cases. We begin with if this is an input port. And so if this is an input port, we are going to write a 0 to the direction register, and that will essentially turn this driver off, and we'll have exactly one operation that can happen, and that is we can read from an input port, and the value of the pin will then, the 0.0 volts will then map to a logic 0, and a 3.3 volts will map to a logic 1. That's an input port. Now, if this reconfigurable pin is an output, we're going to specify that by writing a 1 to the direction register. The direction register is going to be a 1, and this will turn this gate on, such that if I write a 0 to the port register, then that 0 is going to be mapped to an output 0.0 volts. And if I write a 1 to the output, and then that will be mapped to a 3.3 volt output. Now notice also that with an output port, I can read. And so if I read, what I'm going to get is the value of the output port that I'd previously written. So in summary, we can read from an input port, or we could write or read from an output port. And we control this operation with the direction register. Again, 0 means input, 1 means output.